Each hot wire is considered a conductor. All ground wires, regardless of quantity, are counted as a single conductor. Devices are counted based on the number of screw terminals they have. So, a standard receptacle with 2 screw terminals counts as 2 conductors. A standard switch, similarly, counts as 2 conductors. Therefore, if you have a 3-wire circuit feeding a standard switch, you'd have a total of 5 conductors within the box. Considering conductor fill for 14 American wire gauge wire, a 3x7.5-inch box is generally too small for 5 conductors. A minimum of a 3x12-inch box, which offers 8 cubic inches of volume, is needed to accommodate those 5 conductors. The National Electrical Code, specifically Section 314.16a, does provide allowances for using electrical boxes that are smaller than the standard cubic inch requirements, but only if certain conditions are met. One such requirement is that the box's capacity must not exceed 30 cubic inches. This rule essentially eliminates typical switch boxes, since they are generally larger than 30 cubic inches. However, 314.16b introduces another possibility. It permits the use of boxes that don't meet standard box fill requirements if those boxes are gangable. The term gangable refers to the ability to join or connect multiple boxes together to create a larger combined volume. So, if you were considering using a 3x7.5-inch box, an acceptable solution might be to gang together 2 or even 3 of these boxes to achieve the required cubic inch capacity. This is a common practice, especially when dealing with switch boxes. Box fill calculations and appropriate sizing are essential for electrical safety. Overfilling a box can lead to overheating, posing a fire hazard. Understanding the National Electrical Code requirements ensures safe and compliant installations. To accurately determine conductor fill, firstly, identify all the current carrying conductors entering the box, which includes each hot wire and the neutral wire if present. Secondly, count all the ground wires as a single conductor, regardless of their number. Thirdly, determine the device count. Each device, like a switch or a receptacle, counts as a specific number of conductors based on its terminals. Typically, it is 2 conductors per device. Fourthly, refer to National Electrical Code Table 314.16 to find the volume allowance per conductor based on wire size. For example, 14 American wire gauge wire requires a certain cubic inch volume per conductor, and 12 American wire gauge wire requires a different volume. Fifthly, multiply the number of conductors by the volume allowance per conductor based on wire size to obtain the total required box volume. Sixthly, compare the total required box volume with the actual volume of the electrical box. Ensure that the box volume is equal to or greater than the total required volume. Seventhly, consider any additional allowances, such as fixture studs, internal cable clamps, or equipment grounding conductors. Each of these may require additional volume in the box. Consult 314.16b for these allowances. Eighthly, if the box is too small based on your initial calculations, you can either increase the size of the box to meet the required volume or consider ganging multiple boxes together, as permitted by the code. Ninthly, remember that certain types of boxes have limitations in the number of conductors they can accommodate, regardless of volume. Refer to the manufacturer's specifications and the National Electrical Code for these limitations. Tenthly, always consult the latest edition of the National Electrical Code and local amendments for the most up-to-date requirements and regulations. The NEC is updated regularly, so it is essential to stay informed of any changes. 11thly, when dealing with boxes containing conductors of different sizes, calculate the volume allowance separately for each wire size and then add them together to get the total required box volume. 12thly, be aware that some jurisdictions may have specific rules or interpretations regarding conductor fill that go beyond the minimum requirements of the National Electrical Code. Check with local electrical inspectors to ensure compliance with all applicable regulations. 13thly, consider the ease of working within the box when selecting the appropriate size. A box that is only marginally large enough to meet the code requirements may be difficult to work in, making it harder to make connections and potentially increasing the risk of damaging the wires. 14thly, when running cables into a box, use appropriate cable connectors to protect the wires from damage and ensure a secure connection. These connectors also take up space within the box, so factor that into your calculations. 15thly, when installing devices in a box, ensure that they are properly mounted and secured. Loose devices can put strain on the wires and connections, potentially leading to failures. 16thly, if you are unsure about any aspect of conductor fill calculations or electrical box sizing, consult with a qualified electrician or electrical inspector. They can provide guidance and ensure that your installation is safe and compliant. 17thly, remember that proper conductor fill is not just about meeting the minimum code requirements. It is also about ensuring the long-term reliability and safety of your electrical system. Overcrowded boxes can lead to overheating, insulation breakdown, and even fires. 18thly, when calculating conductor fill, it is essential to consider the grounding conductor. While all grounding conductors are counted as a single conductor, they still take up space within the box. 19thly, if you are using wire connectors, such as wire nuts or push-in connectors, choose connectors that are appropriately sized for the number and gauge of conductors being joined. Overfilled connectors can also lead to failures. 20thly, when working with metal boxes, ensure that they are properly grounded. This is typically done by connecting a grounding conductor to the box using a grounding screw or clip. 21st, when installing boxes in damp or wet locations, use boxes that are specifically designed for those environments. These boxes are typically made of non-corrosive materials and have features to prevent water from entering. 22nd, if you are adding new circuits or modifying existing ones, be sure to update the circuit directory at the electrical panel to reflect the changes. This will help prevent confusion and ensure that the correct circuits are de-energized when performing maintenance or repairs. 23rd, when working with older wiring, be aware that the insulation may be brittle or damaged. Handle the wires carefully to avoid causing further damage. 24th, if you encounter any signs of overheating, such as discolored wires or melted insulation, investigate the cause and correct the problem immediately. Overheating is a serious safety hazard. 25th, when installing boxes in fire-rated walls or ceilings, use boxes that are specifically designed for those applications. These boxes are designed to maintain the integrity of the fire barrier. 26th, if you are installing boxes in accessible attics or crawl spaces, protect the wiring from physical damage by running it through conduit or using cable guards. 27th, when installing boxes outdoors, use boxes that are rated for outdoor use. These boxes are typically weatherproof and UV resistant. 28th, if you are installing boxes in hazardous locations, such as areas where flammable gases or vapors are present, use boxes that are specifically designed for those locations. These boxes are designed to prevent explosions. 29th, when installing boxes in healthcare facilities, use boxes that are specifically designed for those applications. These boxes are designed to minimize the risk of electrical shock. 30th, if you are installing boxes in schools or other educational facilities, use boxes that are designed to be tamper-resistant. These boxes are designed to prevent unauthorized access to the wiring. 31st, when installing boxes in public spaces, use boxes that are designed to be vandal-resistant. These boxes are designed to withstand abuse and prevent damage. 32nd, if you are installing boxes in areas with high electromagnetic interference, use boxes that are designed to shield the wiring from EMI. 33rd, when installing boxes in areas with high levels of radio frequency interference, use boxes that are designed to shield the wiring from RFI. 34th, when installing boxes in areas with high levels of static electricity, use boxes that are designed to dissipate static electricity. 35th, when installing boxes in areas with corrosive environments, use boxes that are made of corrosion-resistant materials. 36th, if you are installing boxes in areas with extreme temperatures, use boxes that are designed to withstand those temperatures. 37th, when installing boxes in areas with high humidity, use boxes that are designed to be moisture resistant. 38th, if you are installing boxes in areas with high vibration, use boxes that are designed to withstand vibration. 39th, when installing boxes in areas with seismic activity, use boxes that are designed to withstand earthquakes. 40th, when installing boxes, always follow the manufacturer's instructions and the National Electrical Code. Gang electrical boxes involves connecting two or more electrical boxes together to create a larger space for wiring and devices. This is commonly done when there is not enough space in a single box to accommodate all the wires and devices needed for a particular electrical installation. Firstly, determine the number of boxes needed. Calculate the required volume based on the number of conductors, devices, and fittings that will be installed in the box. Then, determine the number of boxes needed to provide that volume. Secondly, select the appropriate boxes. Choose boxes that are designed to be ganged together. These boxes typically have removable sides that allow them to be connected. Thirdly, remove the sides of the boxes. Use a screwdriver or pliers to remove the sides of the boxes that will be connected. Fourthly, connect the boxes together. Align the boxes and secure them together using screws or other fasteners. Fifthly, install the wiring in devices. Run the wiring into the GAN boxes and connect it to the devices. Sixthly, install the cover. Install a cover plate that is designed to fit over the GAN boxes. Box fill calculations are an essential aspect of electrical work. Proper box fill ensures the safety and reliability of electrical connections, prevents overheating, and complies with the National Electrical Code. When calculating box fill, firstly, you must consider the volume of the box. Electrical boxes come in various sizes and shapes, each with a specific internal volume. The volume is typically marked on the box itself, usually in cubic inches. Secondly, you must consider the number and size of conductors entering the box. Each conductor, including hot wires, neutral wires, and ground wires, takes up space within the box. The amount of space each conductor occupies depends on its wire gauge. The NEC provides tables that specify the volume allowance for each conductor size. Thirdly, you must consider the number and type of devices installed in the box. Devices such as switches, receptacles, and lighting fixtures also take up space within the box. The NEC specifies the volume allowance for each type of device. Fourthly, you must consider the presence of any fittings or connectors inside the box. Wire connectors, cable clamps, and other fittings also take up space and must be accounted for in the box fill calculation. Fifthly, you must add up the volume of all the conductors, devices, and fittings to determine the total volume required within the box. Sixthly, you must compare the total volume required with the actual volume of the box. If the total volume required exceeds the volume of the box, you must either use a larger box or reduce the number of conductors, devices, or fittings. Overfilling an electrical box can lead to several problems. Firstly, it can cause overheating. When conductors are packed too tightly together, they can generate excessive heat, which can damage the insulation and lead to electrical shorts or fires. Secondly, it can make it difficult to make proper connections. Overcrowded boxes make it challenging to work with the wires and can result in loose or improperly connected wires, which can cause arcing or equipment failure. Thirdly, it can violate the National Electrical Code. The NEC sets specific limits on the number of conductors and devices allowed in an electrical box. Violating these limits can result in fines or other penalties. Fourthly, it can create a safety hazard. Overfill boxes are more likely to experience electrical problems, which can put people and property at risk. To ensure proper box fill, follow these guidelines. Firstly, always use the correct size box for the application. Choose a box that is large enough to accommodate all the conductors, devices, and fittings that will be installed. Secondly, minimize the number of conductors in the box. If possible, reduce the number of wires entering the box by using larger conductors or by routing wires through other boxes. Thirdly, use compact devices and fittings. Choose devices and fittings that are designed to take up as little space as possible. Fourthly, properly organize the wires inside the box. Keep the wires neatly arranged and avoid overcrowding. Use wire connectors to bundle the wires together and keep them out of the way. Fifthly, consult the National Electrical Code. The NEC provides detailed rules and guidelines for box fill calculations. Refer to the NEC for specific requirements and recommendations. Calculating conductor fill in electrical boxes is crucial for electrical safety. It's based on the National Electrical Code, which mandates proper sizing to prevent overheating and potential hazards. The process starts with identifying all current-carrying conductors, including hot and neutral wires, noting each wire's gauge since different gauges have different volume allowances, per National Electrical Code Table 314.16. A. Grounds regardless of quantity count as one conductor. Each device, like switches or receptacles, is counted based on terminals, generally 2 conductors each. Add up all conductor volumes and compare the total needed volume with the box volume, ensuring the box meets or exceeds the calculated need. Consider additional space for fixture studs or cable clamps, consulting 314.16. B. And if the box is too small, opt for a larger size or gang multiple boxes, if allowed. Remember, local codes might exceed NEC minimums. Always prioritize ease of wiring and secure connections, and when unsure, consult a qualified electrician. Box fill ensures long-term electrical system reliability and safety, preventing insulation breakdown and fires. Even grounding conductors, counted as one, still require physical space, and use appropriately sized wire connectors to avoid overfilling. Ground metal boxes correctly in use specified boxes for damp, wet, or hazardous locations. Update circuit directories when adding or modifying circuits, and handle older wiring carefully. Address overheating signs immediately and use fire-rated boxes for fire-resistant walls or ceilings. Protect wiring in accessible areas and use outdoor-rated boxes for exterior installations. Hazardous locations require explosion-proof boxes, and healthcare facilities need boxes designed to minimize shock risks. Tamper-resistant boxes are best for schools, vandal-resistant ones for public spaces, and shielding boxes for areas with electromagnetic or radio frequency interference. Boxes should be corrosion-resistant in corrosive settings and temperature-resistant in extreme temperatures. In high humidity or vibration areas, choose moisture-resistant or vibration-resistant boxes, and in seismic zones, use earthquake-resistant models. Always adhere to the manufacturer's instructions and the National Electrical Code for safe and compliant installations.